Welcome, Math 107 students, to the preview exercises of lesson number 4. Lesson number 4 deals with linear equations, solving linear equations, and also rational equations. So let's take a look at these preview exercises, which are designed to help us with some of the skills that we'll need to use in today's lesson. So the first preview activity here asks us to find or to use the distributive property and then simplify the expression below. So let's call this 1a. So as we can see, we have a 12, and the 12 is multiplying two different expressions, two different fractions. So the first thing I'm going to do is take the 12 and multiply it by the fraction x plus 2 over 4. And I'm always very careful whenever I have a numerator or denominator that has two or more pieces to it, which we officially call terms, the parts that are separated by addition and subtraction, I always put it in parentheses. Now you could write 12 like this, or if you wanted to, you could put 12 over 1 if that made you feel better. Okay, but I tend not to try to get my visual field too messy if possible. And now 12 is going to take its turn and multiply the x minus 1 divided by 3 times, and again, I'm going to put that x minus 1 in parentheses over 3. And notice your subtraction is in between. So we basically have a subtraction problem that has this as the first term and that as a second term. Now, where do you go from here? Well, a lot of that just depends on who you are. When you multiply, you don't need common denominators. You can multiply any two fractions regardless of what their denominators are by multiplying the numerator times the numerator and the denominator times the denominator. So in this case, since we know 12 is sitting over the denominator of 1 and 1 times 4 is 4, we can just extend this fraction bar just like this. Now, some of you may want to multiply 12 times the quantity x plus 2 on top, but I think since this is involving subtraction, and I would then have to make sure my two fractions had the same denominator, and that could get really involved, why don't I see if I can make a denominator that has 1? And then I don't have to even think about it anymore. And I can do that in this case because 12 and 4 have a common factor. 12 has 4 as a common factor, and 4 has 4 as a common factor. So this 12 over 4 becomes 3 over 1. So I can write this as 3 times x plus 2. Oh, that's a lot nicer to look at. Similarly, this second box, or my second term here, I have a 12 divided by 3. That becomes the number 4. When I factor 3 into 3, I get 1, and 3 into 12, I get 4. So I reduce this 12 over 3 to become 4 over 1. So now I have 4 times x minus 1. I don't know about you, but I much rather simplify those two boxes and subtract them. So let's simplify each box and keep track of what we're doing with each box by keeping them in these little blank boxes here. So I use my distributive property, 3 times x and 3 times 2, 3x plus 6. I can drop my parentheses because there's nothing happening out here, no operation. I got to be careful in here because I have this subtraction problem. So when I use my distributive property now, I'm going to keep everything in parentheses. So I have 4x take away 4. So I can remove this box. Nothing changes. It's 3x plus 6. But before I can remove this box, I have to subtract the 4x and I have to subtract the negative 4. So remember, when you do that, when you distribute this negative sign, you have to distribute it through either thinking about it as a distributive property, where this would be a -1 times each of those, or subtracting each one of them. So we have 3x plus 6, take away 4x plus 4. And that's the tricky spot right there that a lot of you sometimes, or some of you, may forget to do. So now we combine like terms. 3x minus 4x is -1x. 6 plus 4 is 10, and we're all set. Some of you may choose to write this as the opposite of x, or -x plus 10. Both okay. So the next problem, let's call it 2a, is asking us to solve a linear equation. And I think you've had lots of practice with this, but let's just go through it just in case. So to solve a linear equation, we want to simplify the expression on each side. So the expression on the left-hand side asks us to use a distributive property, which is 3x plus 6. On the right-hand side, I have 10 take away this term. So one of the first errors that can happen here is for you to say 10 take away 5, and then 5 times the quantity x minus 4. This is order of operations, and if you put these little boxes around your terms, you'll never even have to worry about order of operations, because the 10 is just hanging out there all by itself, and you're automatically going to distribute that 5 and subtract, or you're going to distribute a -5. So let's call this a -5. 5 times x, we get -5x, and -5 times -4 is plus 20. So now this becomes 3 terms. We combine our like terms here, 30 minus 5x, and on the left side we have 3x plus 6. So to solve this equation, we bring x to one side and our constants to the other, our x terms either on the right or left, and our constants on the right or left. It's totally up to you. I try to avoid having negative numbers multiplying my x, so I always say, which side do I have the most x on? And I have more x on the left side. I have 3, and on the right side I have -5. So I'm going to choose to add 5x to both sides, and that gives me 8x plus 6 equals 30. And now I have to subtract 6 from both sides. I get 8x equals 24. And then I get 8x equals 24. I can either multiply both sides by 1/8, which is the reciprocal of 8, or undo multiplication by dividing by 8, and I get x equals 3. Now to see if I'm right, I go back to my original equation, and where I see x, I'm going to put a 3, and I'm going to check my work. And I hope you get into the habit of doing this as well. This is an excellent practice to get into. So what do we have here? We have 3 times 5. Does that equal 10 minus 5 times a -1? We take away 4 is -1. We get 15 equals 10 plus 5. 15 equals 15. You're a happy camper. You know you have the right answer. So the solution set here is 3. This is how we write it in our book and in my math lab. You could also just write x equals 3 when you're just doing it on your homework if you want. But if you're asked to find the solution set, then you have to put these little curly braces around 3. Okay, so that's an example of solving a linear equation. And now this is the second part of today's work, solving a rational equation. And again, put those parentheses anytime you see more than one term, whether it's in the numerator or the denominator, just put those parentheses around it to help you think of that as a single quantity. Okay, so here I say, all right, I know in order to do an equation like this, I'm going to have to combine the right-hand side, which means I have to get common denominator. So do I have to change everything there to 6, or do I have to change everything to 12ths all the way around? And you start thinking about this, you get a little nervous. But guess what? This is an equation, which means you have a very powerful tool available to you. That is, you can multiply both sides of this equation by any non-zero number that you want, a quantity. And since you're not being asked to add two things or subtract, where you then have to make common denominators, here you can say, all right, let me find that what would be typically called the common denominator, the lowest common denominator, which is a multiple of all these numbers. And then I can multiply each part of the equation by it, and I'll create 1 in the denominator, and that's a lot nicer to look at. So let's take a look at how we find this common multiple. So if this was all algebraic expressions in the bottom, remember we would be looking at factoring everything. Well, with numbers, we prime factor. So 4 is 2 times 2, or 2 squared. So I'm going to make a circle here that represents 4. And I'm going to write 2 times 2. And then I've got the number 6. To make 6 from prime numbers, I need a 2 and I need a 3. So to make 6, I'm going to borrow that 2 and throw in a 3. So the green circle represents my number 6. And then my other denominator, 3, is already prime. And guess what? It exists right here in this circle. So my common multiple is simply to multiply those numbers right across, and I get 12. So 12 is the lowest common multiple. A denominator, if you were making this into equivalent fractions with 12 in the denominator, you would say LCD. But I'm going to actually use this number 12 to multiply everything on both sides. So that's why I'm changing the name to lowest common multiple. So here's what I have on the left side. What do I have on the right side? Again, I have to multiply everything on both sides by 12 in order to keep that equation in balance. So let's take a look at what this new equation, or this equivalent equation, actually looks like when I do that. So 12 times 1/6 and 12 times 2 minus x all over 3. And again, that fraction bar can extend right across. So now I reduce. 4 goes into 4 once, 4 goes into 12 3 times, and I get 3 times x plus 1, all divided by 1. But guess what? I don't have to write the 1. Yay! 6 goes into 12 twice. 2 times 1 is 2. 3 goes into 12 4 times. 4 times the quantity 2 minus x. Lo and behold, you have this really nice looking linear equation to solve. No fractions. You're happy, you're relieved. So now you just go about your business as you have learned to do when solving linear equations. You simplify each side with the distributive property. And then on the right side, we can combine some like terms. And then you add 4x to both sides. And you get 7x plus 3 equals 10. And you subtract 3 from both sides, and you get 7x equals 10. And, 7x equals 7. And then x equals 1. So your solution set here is curly braces 1. And now you check. So we have 1 plus 1 over 4 is equal to 1/6 plus 2 take away 1 over 3. So 2 over 4, does that equal 1/6 plus 1/3? Well, 2 over 4 is 1/2. 1 over 6 is 1 over 6. 1 over 3 is 2 over 6. Is 1/2 equal to 3 over 6? Yes, 1/2 is equal to 1/2. And you're happy. Okay, that's the preview exercises for lesson 3. Please let me know if you have any questions.